All right. So on this first one, it says write the equation of a circle centered at -2, -5, and the radius of 5. Okay, so remember, when we do performance finals, we're going to write out any equation that we use. Okay, so this is the equation of a circle. And then I'm going to substitute in this information. I'm going to have x plus 2 squared plus y plus 5 squared. And our r is 5. And 5 squared is going to give me 25. Okay, so what you would say on your paper is equation of circle. I would say those backwards. Equation of circle. And then you could go into telling me something about like how this is H and this is K and this is R. And that would be sufficient information. Yep. So I wrote the equation and I showed all my work.
Oh.
Yep. Okay. Now, determine if the point is inside, outside, or on the circle. Show your work algebraically. That means that I have to show all of the steps. I'm not just going to say, hey, from Desmos. Okay, so what I'm going to do is I'm going to take the equation that I have, and I'm going to substitute this in for x and y. Okay, so I'm going to do it for this first one. So I'm going to have -4 plus 2 squared plus 1 plus 5 squared. And we're trying to see if that equals 25. So -4 plus 2 is -2. -2 squared is 4. 1 plus 5 is 6. 6 squared is 36. Because I took the original equation, and 1 is my y value, right? -1. Oh, there we go. Yeah. So -1 plus 5 is going to give me 4. 4 squared is 16. Is 4 plus 16 25? No, but 4 plus 16 is 20. Is that less than 25? Yes. So this is going to be inside the circle. Okay. Can you try B and C? Take a second, try those two. Here's what I got. For B, I got on the circle because 25 equals 25. For C, I got outside the circle because 29 was greater than 25. That makes sense? Anybody need clarification?
What does it mean?
So like on that circle, on the line of the circle. Okay. Questions? Okay, so we're good on 1 and 2. Okay. Okay, so we're gonna go ahead and scroll down. I'm gonna skip over 3. We're gonna go ahead and go to 4 really quick, and then we'll come back to 3 in just a second. Okay, so on number 4 is that a quadrilateral is inscribed, and we're gonna prove that it's a square. But what formulas are we gonna use for this one? Distance, midpoint, and slope. Okay. All right, so just a reminder, distance formula is y2 minus y1 squared plus x2 minus x1 squared. It's okay if you flip-flop these. That's okay. Midpoint is x sub 1 plus x sub 2 divided by 2. And y sub 1 plus y sub 2 divided by 2. And then slope is y2 minus y1 over x2 minus x1. Okay. Go ahead and take a moment and see if you can find the distance for these. Okay. Should have gotten, what's the distance of PQ? Huh? 50. A big square. 50. Okay, so let's try it. So for PQ, I'm just gonna check your work. All right, -5 minus 0 squared plus 3 minus -2 squared. So that's gonna give me 25 plus 25. Remember, you're going to take the square root of 50. That makes sense. Okay, cool. Square root of 50. That sounds more accurate. Okay. For PR, again, you should have gotten the same thing. Square root of 50, square root of 50, square root of 50. Okay, because it's a square. Okay, so that goes ahead and tells you, hey, all sides have to be equal. You just have to show me that they're equal. Does that make sense? Now I am doing this shorthanded. Like I didn't actually write out all my work. You will write out all of your work. Yeah. Okay, I'm not gonna do it right now because that's a waste of time. Okay, for midpoint, you're gonna do the diagonals. You're gonna do PS and RQ, PS and RQ. Okay, so when you do that, your midpoint should be, you haven't gotten that yet, right? Okay, so let's do PS really quick. So we do midpoint for this, that would be -2 minus -7 divided by 2, and 0 minus -5 divided by 2. Oh, nope, it's pluses. I'm so sorry. -2 minus -7 divided by 2. And then 0 minus 5 divided by 2. So that should have given me -9 divided by 2 and -5 divided by 2 for midpoint. Yeah, I added them, but they're all negative. So adding a negative is just subtracting that number. Okay, again, you would show me the same thing with RQ. Okay. Slope, you would find the slope of each side. Okay, so you're going to do y2 minus y1 over x2 minus x1. And you do that for each side. Again, you're going to have that they are perpendicular to each other because they're going to be negative reciprocals, right? Does everybody understand? Okay. I want to jump back up to this number 3 really quick because we didn't really talk about this one that much when we were going over circles. So I just kind of want to hit it one time. So when I have the equation of a line that's tangent to the circle at point -6, -2. Okay. All right, ready? Okay. So I had the equation from the top, which was x plus 2 squared plus y plus 5 squared equals 25, right? Now, we want it to be tangent to this circle at this point, right? Okay, so we're going to take the point -6, -2. Okay, and we're going to find the slope. Okay, so we're going to find the slope of that using our center. Okay, so we're going to take these points as x1, y1, and then this one's going to be x2, y2. Okay, so we're going to do -2 minus, and this point is going to be -5, right? So we're going to have +5 over -6 minus -2. So this slope is going to be 3 over -4. I'm going to give you a second to catch up. Okay, so this slope right here, ready? Okay, this slope right here is -3 over 4, right? Okay, so this line represents that slope. If we were to actually take this line and move it down, it would cut through this point, but then it would cut through the circle again, right? So we don't want that to happen. We're going to change this to the opposite sign. Okay, that way it's only going to touch the point once. Okay, so when we do this, we're going to take, I go back here. We're going to take, remember point slope form? Okay, so y minus y1 equals m times x minus x1. Okay, so we change the sign to be 3/4, positive 3/4. We're going to plug that in for our slope, and we're going to use this point and plug in. Okay, so all we did was we found the slope between the point that they give us and the center, change the sign of the slope so that it only cuts through the circle one point, and then use point slope form to plug in. Remember, area is length times width, and perimeter is going to be add up all sides. You found the distance of this square already, right? You all told me it was the square root of 50, right? So if I find the area, then that means I'm going to take the square root of 50 and multiply it times the square root of 50. So the area is going to be just 50. And you can say units squared if you would like. For perimeter, we're going to add up all sides. So we're going to say square root of 50 plus square root of 50 plus square root of 50 plus square root of 50, or you could just multiply it times 4. And that would give us 4 square root of 50. You could use the graph. Yeah, that might have helped you in the last problem. Yep. Talk about two-way tables. Okay, we just covered that last week. I know it's very recent. There's going to be 2 problems that you're going to be able to choose from. Okay, one's going to be about circles and basically everything that's on the front. And then another one's going to be on this probability. I know we're new to it, so if you don't want to do the probability, that's okay. Okay. So the reporter asked 150 voters if they plan to vote for a new library and a new arena. The table shows the results. The first thing you want to do is total up all of the rows and columns. Okay, so before we even look at the problems, we're going to go ahead and total it up. So we're going to have 78 here. This will be 72 here. This will be 51 here. And this will be 99 here. So for a grand total of 150. You just want to check and make sure that your rows and columns add up to whatever they already stated. If it doesn't, then it's going to impact your numbers later on. Okay? You want to make sure that whatever number they said, like the total number, is the number that you get right here when you add up the rows and columns. Otherwise, you're going to have some issues. All right, so on part A, it says, given that a voter plans to vote no for the library, what is the probability that they vote no for the arena? So remember, we learned last week, conditional probability, that given that a voter votes no for the library, what's the probability that they vote no for the arena? Okay, so out of the people who said no for the library, so out of the 72, how many voted no for the arena? So you're going to say 42 out of 72. And that's going to give us, somebody help me with that. Thank you. 58%. Okay. So what percent of voters plan to vote no for both a new library and a new arena? So out of the 150, how many vote no for the arena and no for the library? 42 out of 150. Okay, so you're going to go into your calculator. You're going to type 42 out of 150, which is 28%. Okay. On part C, it says, given that a voter plans to vote yes for the arena, but out of the 51, how many will vote no for the library? So out of the people who vote yes for the arena, how many are going to vote no for the library? 30. I think I have those labeled. Yeah. 51. Out of 51, 30 voted for it. Okay. So it's 58%. Okay. What? You can. So if you gave me like 59% instead, that's okay. All right, ready? What is the probability that a randomly selected voter will vote yes for a new library, given that they vote yes for a new arena? Okay, so out of the people who voted yes for the arena, out of the 51, how many voted yes for the library? 21. Okay, so 21 out of 51 gives me 41. Okay. All right, go ahead and take a moment and look at number 2. You're going to create a two-way table from that scenario. Let's do math. Okay, for some reason they had these numbers wrong. So just make this 108. I'm sorry. It shouldn't be 118. It was like 10 over. I'm so sorry. Okay, so you should have like one column that's like downtown, one column that's like midtown, and then on time, and then did not make it on time. Okay, so if I took 108 and I subtracted 69 from it, what would I get? Okay. And then if I took 172 and subtracted 75, what would I get? Say again. 57. Yeah. Okay. 132. Yep. Okay, so then 75 plus 69 would give me what? 144. And then 57 plus 39 would give me what? One what? Okay. No, not 196. 96. Cool. You have to be for real. Listen, it's been a long day. Okay, so this would be my two-way frequency table. Does that make sense? Okay, are there any questions about this? So like these problems aren't super bad. You just got to understand how to find the probability, right? Okay. Yes. It says two-way table. You're doing great. Oh no. Okay. So. So then there are some questions on the next page that says, what is the probability that a delivery made by downtown staff is late? Okay, so out of the 132 from downtown. Okay, so out of the 132, how many were not on time? 57. 57 out of 132. And that would give me 43%. Yes. Bro, 43% of the time is going to be late. They're going to be losing money, right? Can you conclude that pizza delivered by downtown location and being late are independent events? This is not going to be on there because we haven't talked about this yet. Okay, so do you remember what they are? Go ahead. Okay. Affect each other, like basically saying like if you get off time to work, like traffic could affect you, your car could go out, stuff like that. That's a dependent example, right? Okay. So if you want to do this one for a little bit of extra bonus, this is how you would go about doing it. It has to be the probability of B given A is equal to the probability of B multiplied by the probability of A and B. Now, what this really means is that the probability of the intersection of the two things that actually happen. Okay. This is multiplying.
Not a dot or so that's the mark on the board.
Oh. I was like, I didn't do that. Okay, I don't expect you to do this because we haven't talked about it yet. Okay, so I don't expect that. Now, if you want some extra practice, you can do number 3. I just included it just in case you did want to get some practice in. But Thursday, you will have your performance final. Tomorrow, it's not that you have a free day. You have like 10 minutes of work. 10 minutes. That's all I'm asking for. Okay? It will be on e-class. I gotta post it. Okay?